Okay, this video is about the distance formula. Now, the distance formula is a formula that we can use to find the distance between two locations on a coordinate plane. Now, most textbooks, most people are going to tell you that the distance formula is found by literally following this formula. All right? This is definitely a way that you can do it. In order to activate this formula, though, you need to have 2 points. The first point we identify as x sub 1, y sub 1. And the second point we identify as x sub 2, y sub 2. We then take the values in those different spots, plug them into the formula, and simplify the formula. Okay? Now, I personally like to do the distance formula by thinking about what I'm doing, not just using the formula. So the technique that I use is I subtract the x's and square them. I subtract the y's in the same order that I subtracted the x's and square them. I add those results together, and then I take the square root. Usually they're going to ask us, when you take the square root, they're going to ask us to round to the nearest tenth. Remember, that's 1 decimal place. So for example, let's say that we're given these points, okay? I recognize that this is an x, this is a y, this is an x, this is a y. In any particular order, I'm going to subtract my x's. Now, I'm going to choose to go -1 minus 2, which will give me -3, and then square that, and that gives me 9. I'm now going to subtract the y's, and it has to be in the same order that I did the x's. So that means that I'm going to take 8 minus -8, which would be 16. I have to square 16, and for those of you that don't remember, 16 squared means 16 times 16, which would be 256. I know that my distance is equal to the square root of 9 plus 256, which would be the square root of 265. Now, I can't find the square root of 265, or it's not perfect, so I'm going to go to my calculator here and type in 265 and take its square root. I'm going to round this to the nearest tenth. In this case, it would be 16.3. So that means this is approximately equal to 16.3, and that's how you find distance. It's literally this simple if you can follow the steps. All right, so let's look at this next one here. All right, I'm going to find the distance by first subtracting the x's. 1 minus 0 is 1. And then square that result. 1 squared is still 1. I'm going to subtract the y's in the same order. -5 minus -7, which would be -5 plus 7, or 2 squared, which is 4. Therefore, I know that my distance is the square root of 1 plus 4, or the square root of 5. Now remember, the square root of 5 is an exact value. All right? It's just an irrational number. If I need to approximate it or round it, I'm going to take the square root of 5, and this would stay at 2.2. Now, one step further that they could do here is they don't give you any coordinate points, and they want you to find the distance of this segment. It should still be easy as long as you can identify the points on this coordinate plane. For example, I know over on the left here, I have the point -5, 0. Up kind of in the first quadrant here, I have the point 3, 3. Once I've identified those two endpoints, it's exactly like what we just did. So I'm going to subtract the x's, -5 minus 3, which would be -8 squared, +64. Subtract the y's in the same order. 0 minus 3 is negative 3 squared is 9. I know that the distance is the square root of 64 plus 9, or the square root of 73. And again, to approximate it, I'm going to take that and use my calculator, and I get that that's about 8.5. Please complete the worksheet. Hopefully you guys have no problem with this.